So as you look at it, we're going to dive into a couple things today, but I'll kind of pause here. So who here has like a DevOps background? All right. Who here really cares about security? That's what I was hoping to see. Great. All right. So to kind of dive into a specific topic, we'll just take a very specific scenario and we'll kind of build from there. As you might or might not know, on AKS, essentially when we look at it, the worker nodes are essentially a shared responsibility. So with that in mind, as I'm using AKS, I'm concerned from a customer perspective, how do I ensure that that node that I'm running my applications on is secure? So how do I patch it? How do I protect from breaking changes? And essentially overall, how do I protect that worker node from all the threats that exist out there in the ecosystem? So diving into that, the idea is that we're going to talk through securing your AKS worker node specifically. So starting out, there's a series of nodes that we have on AKS. So if you do an AKS create, you're going to get an Ubuntu node as an example. That's just one flavor. We also have FIPS as an example. So if you're looking for FIPS hardening, we have all the necessary crypto modules that are loaded on this particular SKU. You can do an AKS create, attach a node pool, and you'll get those FIPS crypto modules there. This is based off of 140.2. We are doing the work, starting the work on 140.3 as well. Another tidbit as well is now that we have the node pool as FIPS enabled, we are working on a FIPS enabled control plane as well. Just a little tidbit there. Additionally, as you look at the OS and data disks on those worker nodes as well, we also bring the encryption capabilities there as well to ensure. So host-based encryption to ensure that the temp, the ephemeral, the OS disk, data disk are all encrypted. And whether it's platform managed or BYOK, we have both those options for you. Depending on what you're looking for as well, we also have dedicated host capabilities. So instead of running on a shared host, you could, a lot of customers that are worried about tenancy as an example, noisy neighbor, will deploy a dedicated host for their environment. You can attach that as a capability into your cluster as well. So to start to do some hardware level isolation. So depending on your requirements, this is one option that exists for you as well. The idea is that this gives you the control over your physical host, so you can choose which applications sit on that, getting dedicated networking, dedicated compute from that model as well. I talked about, we have Ubuntu as our default OS, so to speak. We also have Azure Linux, as you might be aware in the ecosystem that used to be called Mariner. This is another flavor as well. This is our Microsoft-built, commercially available OS that's available on AKS as an alternative. We've been running it internally at Microsoft for about 3 or 4 years now. A lot of customers, internal customers, have dog-fooded it. It's been GA and AKS for a little over a year now, and many customers from startup through Fortune 500 are running that. The big thing is that when we look at Azure Linux, it's obviously, we're focused on security and secure pipeline and those particular capabilities. So essentially, we manage everything from the source code, building packages from source, publishing, signing those packages is a big part of that capability as well. And I said all the building is with an emphasis on security. One of the other big things as well is that when we built this out of the box, it's essentially CIS hardened to level 1 right out of the box. So if you look at Ubuntu as an example, Charles will get in this a little bit as we kind of go through, but that's one of the big things that comes from CIS as well. Another thing that's really interesting about this as well, we have a lot of different key capabilities that I'll talk about here in a little bit as well that we're building out around more levels of isolation. A lot of that stuff's coming through our Azure Linux implementation. Upcoming, you'll see some work in development as well around kernel level patching and our container optimized host. This is one is near and dear to my heart. So the idea is you have a true cause that's on AKS. This is something that's going to be coming very soon. All right. So building on top of that, one of the next key capabilities we have is around pod sandboxing. So taking that Azure Linux host, so now we can start to carve that up think of that building a nested VM on top of that, that VM itself, so you can start to do some isolation within your application. So instead of an application running on that shared kernel down below, with that nested VM capability, each application is running on its own isolated kernel capability. So think of now starting to build environments for trusted versus untrusted applications. Since it's just a SKU, it's just a runtime from a capability point of view, you can deploy a node pool that's Azure Linux enabled that has that capability, and depending on what you specify in your application is whether it's running on the shared kernel or within the shim, so to speak. So that really means that you're not really worried about any code changes. So you can dynamically move your application across the ecosystem as you build your clusters. All right. On top of that, another big thing that we released out is a security patch channel. So is everybody here familiar with unattended update and how we did it on AKS? So that was essentially our default capability that we had out in the ecosystem. And so when we look at it, like I said, that's been there for a good 4 or 5 years on AKS. And so as we looked at it, there were obviously a couple of different challenges that customers ran into. So we started looking at a better way to deliver this. So security patch channel is essentially turns off that unattended update. And so now you get a true secure delivery practices enabled environment so that now you can ensure that when those patches come, they've been vetted and tested and validated in your environment. So the idea from this channel is essentially when you build it out, think of it as you're essentially building a security patched VM that all your AKS clusters will build out. So you'll stamp this, you'll make it available in your subscription, so to speak. So now as you build Node Pool 1, Node Pool 2, Node Pool 3, they're getting that patched VM as you're kind of going through. So, and that's obviously a vetted, capable VM that you have in your environment as well. So as you're consuming those security patches, it's all secure, so you don't have to worry about, you know, patch issues or kernel issues that might break your applications. On top of that, we have another capability called Image Cleaner. So as you look at it from a securing your node capability, one of the topologies of the node is obviously images that are cached on the node. One of the fundamental problems that exist in the ecosystem is that as you're caching these images on the node, everybody's pretty standard from a DevOps perspective, caching version 1, version 2, version 3 on that node. And then over time, you get that bloat, and all that bloat represents risk. So Image Cleaner is just an automated job that runs behind the scenes on your node, which will purge all those unused images off your system. It runs automatically behind the scenes, you don't have to think about it. There's a couple of different capabilities, so think of is running equals true is one parameter that you might leverage for Image Cleaner. That's essentially the default behavior. But if you want to look at it, hey, I want to purge off all the high or critical CVEs off my node, I can run that topology as well. This also supports exclusion, so think of like you want to cache a specific set of images. You will assume that risk. You can set those in exclusion, and then filter that off from a capabilities point of view. Disabling SSH. This is now in public preview. This is something we've been working on for a while. The idea here is that traditionally, customers had to manage SSH on their own, whether they did a firewall rule or an NSG. But now this is just a managed feature that exists on AKS. You can just pass a feature flag and we'll turn off SSH on your environment. This works on existing clusters, on new clusters, so it's just something you can essentially just turn on. So now the big thing you kind of be concerned with is, hey, I've just disabled SSH, now what? So from our perspective, it's just Kubernetes, right? You can use debug node. That's always there. As long as Kubernetes is up, you can use debug node, and everything's fine. We also have the AKS run command, command invoke. Everybody might have heard that. I'm not sure if you heard of that. That's another key capability you have as well. You can run remote commands against your cluster, restrict that against policy as well. But because we have the capability to disable run command, we also have the ability to enable it. So think of like break glass scenarios, where essentially you turn off SSH to be compliant with your environment, but you have a break glass scenario, you can just run an AKS update on that cluster and now re-enable SSH and come in and do your SSH work and then turn it back off. You have those flexibilities that exist for you as well. On top of all of the stuff that we've talked about, if you look across Ubuntu and FIPS and Azure Linux, from a key capability, we're also working on bringing the Azure Confidential Computing capabilities directly into AKS natively. So there's a series of work streams that we're doing to bring the entire confidential suite from Azure directly available on AKS. So starting out, we've had confidential VM. This has been GA'd for quite a long time on AKS. So think of this across the AMD SKU set. We are working on the Intel TDX. So if you have that, that's coming, something that's coming very, very soon as well. But the idea is that you take that VM and now you wrap encryption around that VM and all the applications within that VM. So think of creating a trusted execution environment around that node and all the applications that exist on that node. Once again, if we take that core principle that we had from the pod sandboxing I talked about, there's no code changes required. I can just basically go through and create a CVM node pool down below that's all running on Ubuntu as an example, because that comes from the open source community as well. And then I just drop my applications on that node pool, and those applications are now encrypted within that boundary. Some of you might have heard as well, we also have confidential containers, which is a higher level of isolation within that application topology as well. So now, within that, because now it's built on top of the pod sandboxing capability, so if you look at that nested VM capability, we bring Kata into the ecosystem, and now we're wrapping encryption around that. So this is bringing together two open source initiatives around Kata and confidential container from the Open Infra conference, so to speak, compute infrastructure. And so the idea there is that now with that capability, we've brought it as a managed add-on. This provides container-level sandboxing and isolation. And so this is all based off of code integrity, and once again, it's just a runtime class within your application. So once I've deployed that Azure Linux SKU, I now have Kata there, I have Kata CC, are basically runtime classes, and I have that shared kernel, right? So I could go through and have my application, I could basically just specify a runtime class in an application, it'll move across the different topologies. I've got it run on the shared kernel. I pass a switch in there, and now I've dropped it in the Kata implementation. I pass another different switch in there, it moves it over to the Kata CC implementation. So we've just built the native Kubernetes capabilities in there so you don't have to refactor your application to move it across the construct. So as you look at your compliance, you can just move it across the ecosystem to ratchet up your compliance with your organization without having to redeploy your node pools. And then lastly, we just announced trusted launch as well. So if you think of that VM, the boot kits and root kits there, so now at the kernel level, so essentially what we've done here is through trusted launch brought in VTPM capabilities and secure boot capabilities. So think of signed drivers as an example. So if you look at the public preview, how we've done it right now is that you can go through and enable the feature flag, and then you can essentially turn on trusted launch, and that comes with that VTPM capability. When you look at secure boot, the big thing you want to be concerned with secure boot is that essentially all the drivers you're leveraging are signed. So now that we're in public preview, one of the pieces of work that we're doing is looking at the ecosystem and what drivers everybody's leveraging so we can ensure they're signed out of the box. Once we move to GA, the idea is that we're looking at VTPM on by default as an example, so you're essentially getting that security benefit out of the box, right? And then secure boot, you can always turn that on, right? Because the risk there is if you don't have those signed drivers, when you boot your AKS node, it won't boot because you don't have those specific drivers. All right. So with all of that, now we'll kind of dive into the coming soon topology, and I'll bring Coco Wang up to talk through that.
Thank you, Michael. So hey everyone, my name is Coco Wang, and I am a product manager of Azure Kubernetes Service. Today, I would like to introduce some upcoming security features here to secure our AKS workloads. The first one is about network isolated cluster. As we all know, today with a private cluster, the AKS cluster still has the egress requirements. So they are for our system components like mcr.microsoft.com. And with network isolated cluster, the cluster can be bootstrapped, serviced successfully. We don't need to configure any public egress here. Also, we introduced a new outbound types, equals none. That means a cluster can be created without any load balancer, firewall, and net gateway. So like the diagram showed on the right, suppose it's a private cluster. The AKS worker nodes, they can connect to the AKS control plane privately. Also, for the image part, the images will be pulled from the private ACR to the AKS worker nodes. The worker nodes doesn't need to talk to internet anymore. So this AKS cluster is a total isolated cluster, which is a secure environment. Now let's move on for the AD-SSH. Nowadays, the SSH service, they are turned on by default on the AKS node ports. Like Michael mentioned above, we can use the disable SSH to turn off all the SSH service on the node port level. But there is a situation that we still want to allow a specific users to SSH the node ports for maybe troubleshooting, for deployment. If in that scenario, AD-SSH can help. So AD-SSH allows admins to assign SSH permission to cluster users. If in that case, only the users with SSH permission can access the nodes. The other users, local users, even they are with SSH keys, they will be blocked. So this feature supports enabling and disabling on existing clusters. Next one, let's talk about service connector. I think some of you might have tried the managed identity or workload identity. We always use them to connect from AKS ports to the Azure backend services, like the database, like the Azure keyword. So what are the steps we need to take here manually? Let me take workload identity as an example. We need to create the manager identity. We need to get the OIDC issuer. We need to create service account, and so on. Now with service connector, all the steps circled in red, they will be deployed automatically. We don't need to care about them. And the only things we need to do are creating a manager identity and deploying our applications. So it definitely saves a lot of time and effort here. Now let's move on the image part. Today, when we are querying images from external sources, it asks us to build the customer pipeline. Artifact sync will help us to automatically pull the new images from other sources like Docker Hub into our Azure Container Registry. It definitely avoids the throttling and improves the performance. Also, it can help to quarantine the images and run the quality tools like vulnerability scans, signature, and SBOM validation. So now we have the images, but there is a problem. The images in the registry, they can accumulate vulnerabilities, and they are rarely updated with the latest OS patch. So what can I do here? With the predefined ACR tasks, it can help us to use the project named copacetic to patch OS vulnerabilities automatically with a regular basis. It will ensure that the images on the container registry, they are always up to date. We don't need to being impacted by the vulnerabilities. So the final one is about imds restriction. Now I want to introduce the imds endpoints. What are the endpoints? imds endpoints is an internal IP address it exposes the sensitive data and details. So now the pods, all the pods running on the AKS clusters, they will connect to the imds endpoints. So we users always deploy the network policies to prevent such risk. With imds restriction, it's a managed AKS feature, and it prevents the pods from accessing the imds endpoints. But there is an exclusion list that the pods running with host network, they can still access to the imds restriction. So here is a demo for this fancy feature. Let's see it together. Firstly, let's enable this feature on our AKS cluster. And then we use the Azure commands to log in the cluster. Now we are deploying a pod. The pod is set the host network as true. And we log in the pod using the kubectl exec. And now we are installing the curl tool to test the networking. Okay, so then we are using this command to test the traffic from the pod to the imds endpoint. The results turned out that the connection is fine. The pod can still connect to the imds endpoints. Now let's create a second example pod. The pod host network is set as false. Okay, pod created, and let's log in. We are logging the pod and installing the tool again to test the traffic. Yeah, the tool is installing. Fine here. Then let's use the same command to test the traffic to the imds. About 2 minutes later, it turns out the timeout result. That means the pod cannot connect to the imds endpoint anymore. The traffic is blocked. So here is our demo conclusion. Only the pods with the host network, they can still access the imds endpoints, and all the other pods, they will be blocked. So here is all I have for today, and now I would introduce my colleague Charles to maybe bring more details on the security additional investments. Yeah, thank you.
Hi everyone. First, thanks Coco, and this is Charles. I'm a technical program manager of AKS, and today I'm going to bring you some of the latest AKS offerings for you to increase the security posture and the compliance rate of your AKS workloads. So the very first one is image integrity. So today, the container supply chain security is becoming a rising concern of both enterprise customers and the individual developers. So the deployment of your application could be very dangerous if your container image is tempted by a malicious attacker. And the popular solution to such risk is to sign and verify your image before deploying it. And with that being said, the entire process could be very much complex since there are a lot of components involved here. So that's why we bring you image integrity. So instead of moving back and forth with the verification engines, the admission policy controller, the key vaults, the registries on your own, with image integrity, what you need to do is only simply to assign a Azure Policy assignment on AKS cluster, and the add-on and all its prerequisites, the dependencies will be installed for you automatically. And you can then verify if your image have been signed and safeguard your deployment on AKS. And the best part is that we are going to support both notary and the co-signed signed signature, which is the two of the most popular signature formats today. And the second thing I'd like to share with you folks is the CIS-related offerings of AKS. And CIS here standing for the Center of Internet Security. And it represents industrial standards and the best practices for the cybersecurity. And with their products, including the CIS controls, the CIS benchmarks, you can easily reach your security baseline and meet the requirements of different laws and regulations standards. And for your reference purpose, we provide the attestation reports for the AKS container image as well as the node hosted image against their corresponding CIS benchmarks. And we are going to introduce you the CIS hardened node image for Linux Ubuntu and the Windows soon, like what Michael has shared with you just now. And what is even better is that we are going to provide you with a building AKS policy initiatives for you to help audit the clusters and remediate those config risks against the Kubernetes benchmark. And that is going to be available in the near future. And since we have been talking about the AKS building policies, so lastly, I'd like to share some of the latest capabilities of the AKS policy. Sorry, I mean the Azure Policy add-on for the AKS. And the Azure Policy here, it extends the gatekeeper, which is an admission controller webhook for Open Policy Agent. And you can use Azure Policy add-on to apply a skill enforcement in a centralized manner. And with that being said, we have recently introduced 3 new features. The first 2 is the mutation policy as well as the cluster inventory policy. So the mutation policy can help mutate those requests even at runtime. And the cluster-wide inventory policy checks those already existing resources. So both of them, the purpose is to help you raise the compliance rate of your AKS cluster to a higher level. And lastly, as George shared earlier just now in the deployment safeguards, we are going to bring you an improvement for the audit policies, and it is called the warning mode. That's because we want to help solve the pain points that currently the audit policy, they always bypass those non-compliance resources without easy notifications. So that's pretty much I'd like to share with you today. So thank you, everyone. I will have Michael back to us.
Awesome. Thanks, Coco and Charles. So just for conclusion from our perspective, I just want to open it up if there's any questions about anything that we covered today. Okay.
Question, Copperfetic in the ACR, there's an image in, how is the new tag generated? One of the image then deleted?
As far as Project Copacetic. Okay, so I guess to kind of help everybody out, we built a open source capability called Project Copacetic, which essentially deals with the OS level vulnerability. So if you break down an application, obviously you have the application tier and then the OS tier down below. So Project Copacetic really deals with that OS particular layer. So by integrating it with ACR as an example, which is one of the entry points that we did, you're bringing Project Copacetic there. So now as you're building version 1, version 2, version 3, as I kind of mentioned with Image Cleaner as well, so think of that on the cluster side. Now if you shift left a little bit, now look at that same capability with an ACR, but also not only alerting to the fact that there's vulnerabilities there, but now starting to auto-patch those vulnerabilities as well. So as they're brought in the cluster, they're now patched, at least from an OS perspective. And so that's kind of, if you look at the chain, so to speak, that's where Project Copacetic comes in to ensure that what the cluster is running, before it even gets to the cluster, at least the OS level vulnerabilities are remediated on the way in.
But when you have an image in the ACR, for example, version 1, Copperfetic creates the patch, how is the new tag then generated?
Is the new check?
The tag,
Oh, it's
image tag. How is it
because essentially it's going to go through and create, version 1. So think of it as like iterating through. So you've got version 1.1, now it's going to be version 1.1.2 or something like that, as an example. So yeah, it won't be running the same tag, because obviously you're building a new image that's going to kind of run off that. Because at the end of the day, you still own that image, right? And so what we're doing is giving you a patched version of that you can consume and kind of move out from an automation perspective. Is it GA'd? Go ahead, Coco.
It's not yet, but we hope to make it public preview at the end of March. Stay tuned. Yeah, thanks.
Anybody else? All right, so obviously we'll be here the rest of the week. We'll be at the talk, so if anything comes up and you want to pull us aside, more than happy to talk to you. Thank you very much, everybody.